Alright, today let's have a look at the solutions to homework of topic 6. All the questions are related to proportions. Alright, first question. A chocolate chip cookie recipe that produces 30 cookies calls for 2¼ cups of flour. If the math club decides to make 15 dozen cookies for a bake sale, how many cups of flour will they need? So if we let C stands for the number of cookies, and F be the number of cups of flour, then the ratio of C over F must be constant, right? Since we know when C is 30, F is 2¼ so that means 9/4, right? That should equal when the number of cookies is 15 dozens. We need to find the number of cups of flour, right? Oh, sorry, 15 dozen should be 15 times 12, right? Okay, then according to cross product, we have F equals 15 times 12 times 9/4 divided by 30, right? And if you simplify this will give you a 3 here. And then we can cancel a 3. Then cancel a 5 common factor. So that leaves us F equals 27/2. And the unit should be cups, right? So we need 27/2 cups of flour. Okay, have a look at the question here. Any questions, just let me know, okay? Okay, then let's see the next one. Question number 2. 5 people can mow a lawn in 12 hours. How many more people are needed to mow the lawn in just 3 hours, assuming each person mows at the same rate? Okay, we know the number of people mowing and the time required to mow are inversely proportional, right? So if we let N be the number of people and let T be the amount of time, then we know N times T or N times T equals 5 times 12, which is 60, must be a constant, right? And if M people can mow the lawn in 3 hours, then we must have M times 3 equals 60 as well. Therefore, we have M equals 60/3, which is 20, right? Therefore, we need to add 20 minus 5, which equals 15 people to the job. Any questions? Okay, if no questions, let's have a look at the next one. Suppose A is jointly proportional to B and C. If A equals 4, when B equals 8 and C equals 9, then what is A when B equals 2 and C equals 18? So if A is jointly proportional to B and C, that means there exists a constant K such that A over B, C equals constant K, right? And the question tells us that if A equals 4, when B equals 8 and C equals 9, that means we could calculate the value of K, right? Which equals 1 over 18. And therefore, we know when you know B and C, you could solve A, right? So A equals B, C times K, which means when B equals 2 and C equals 18, we have already solved K, which is 1 over 18, right? Then A is 2. Any questions? Alright, if no questions, let's have a look at the next one. Alone, Brenda can dig a ditch in 5 hours. If Jack helps her, the two of them can dig the ditch in 3 hours. How long would it take Jack to dig the ditch himself? So we don't know the time taken for Jack to dig the ditch himself. So we could let J be the time in hours it takes for Jack to dig the ditch himself. Then we know the work rate of Jack, Brenda, and their combined work rate, right? So we know the work rate of Jack is 1 over J, and Brenda has a work rate of 1 over 5 because it says Brenda can dig a ditch in 5 hours alone, right? And their combined work rate is 1 over 3 because the question tells us that if two of them work together, they could dig the ditch in 3 hours. Therefore, we know the combined work rate should equal Jack's work rate plus Brenda's work rate, right? And we have one unknown variable J and one equation. We should be able to find the value of J, right? So first of all, we can move 1/5 to the left side. This gives us 1 over 3 minus 1 over 5 equals 1 over J. And this gives us, we could rewrite the left side using the common denominator 15. So 5 minus 3 here equals 1 over J. Therefore, we know J should equal the reciprocal of the left side, which is 15 over 2. And that gives us, well, you could just keep 15 over 2 there. And the unit is hours, right? Therefore, we know it will take 15 over 2 hours for Jack to dig the ditch himself. Okay, have a look at this question here and let me know if you have any questions. Alright, if no questions, let's have a look at the next one. Question number 5. Planes traveling between city A and B, which are 2,000 miles apart. City A is due north of city B, so suppose this is city B and this is city A. And there is a strong constant wind blowing due south. So this is the direction of the wind. And at constant speed, it takes a plane 5 hours to go from A to B with the wind at its tail, but 8 hours to go back when facing this headwind. What is the speed of the wind? So apparently we have two unknown variables. We don't know the speed of the plane without the wind, and we don't know the speed of the wind, right? So we could let P be the speed and the unit is miles per hour of the plane if there is no wind. And we could also let W be the speed of the wind. And unit is also miles per hour. So with the tailwind, the plane then flies P plus W mph, right? Since it covers 2,000 miles in 5 hours, then we have an equation like this: 5 times P plus W. Speed times time equals the distance, which is 2,000. And when the plane flies into the wind, its rate is P minus W mph, right? And it covers 2,000 miles in 8 hours. That means we have another equation, 8 times P minus W, also equals 2,000. So basically you have a system of two equations like this, and there are two unknown variables, so we should be able to find the two unknown variables, right? Okay, first we can simplify the system. Original system is equivalent to P plus W equals. You can divide both sides using 5 in the first equation. So this gives us 400 on the right side. And we can divide both sides of the second equation using 8. So P minus W equals 250, right? And then we could use the first equation plus the second equation, which gives us 2P equals 650, which means P equals oh, actually we don't have to solve P here. We need the speed of the wind, right? So we could use equation number 1 subtracted by equation number 2. and this gives us 2W equals 150. And then we can solve the speed of the wind, W equals 75, and the unit is miles per hour. So we could conclude the speed of the wind is 75 miles per hour. And again, you don't have to solve the speed of the plane without the wind, because question only asks the speed of the wind, right? Okay, have a look at the solution here. Any questions, just let me know, okay? All right, if no questions, let's have a look at the next one. Number 6. Sunny runs at a steady rate and Moonbeam runs m times as fast, where m is a number greater than 1. If Moonbeam gives Sunny a head start of h meters, how many meters must Moonbeam run to overtake Sunny? So basically, suppose this is Sunny, and Moonbeam gives Sunny a head start of h meters, so this is a Moonbeam, right? Moonbeam has a greater speed, so eventually they'll meet somewhere here, right? And this distance here is h meters. So the key is to equate the times during which they are running, because the time during which they're running is actually the same, right? So we could equate the times during which they are running. So for Sunny, the distance it runs is, okay, suppose we let the total distance from the starting point of Moonbeam and the point where they meet be d. Let d be the distance Moonbeam must run to catch Sunny, okay? And we use unit meters. So But for moonbeams, the distance it runs is d. Sorry. Therefore, we have d minus h over s should equal d over ms, right? And then remember, we want to solve d, right? So you can treat anything else as constants. We need to solve d. Therefore, we could use cross product. We have ds equals dms minus msh. Then msh equals ms minus s times d, right? And this gives us d equals m minus 1 times s over msh. Of course, you can cancel the s there. Oh, sorry. D should equal msh over m minus 1 times s. Then we could cancel a s here. Therefore, we know d is mh over m minus 1. Did you get it? Okay, have a look at the solution here and let me know if you have any questions, okay? Okay, if no questions, let's have a look at the next one. Number 7.
Teacher, I haven't finished copying down the answer. Can you scroll? I didn't finish copying down the answer. Thanks. I finished. Thanks.
Okay, number 7. Because A is directionally proportional to B, and A equals 2 when B equals 5, we then have A over B equals 2 over 5, right? And because A is inversely proportional to C and A equals 2 when C equals 9, then we have AC equals 2 by 9, which is 18, right? Therefore, when b equals 3, we have a equals 3 equals a over 3 equals 2 over 5, which gives us a equals 6 over 5. Since AC equals 18, we have 6 over 5 times C equals a constant 18, right? Therefore, we can solve C is 18 times 5 over 6, which gives us 15. Any questions? Alright, if no questions, let's have a look at question number 8. Again, this is a typical work rate problem. Homer began peeling a pile of 44 potatoes at a rate of 3 potatoes per minute. 4 minutes later, Christian joined him and peeled at a rate of 5 potatoes per minute. Once they finished, how many potatoes had Christian peeled? So we know that after 4 minutes, Homer has peeled 3 times 4 equals 12 potatoes, right? So there are 32 left, because 44 minus 12 is 32. And together, Homer and Kristen can peel 3 plus 5 equals 8 potatoes per minute, right? So it takes them 32 over 8, which equals 4 minutes to peel the rest of the potatoes. In those 4 minutes, Kristen peeled, well, we could use his rate, which is 5 times 4 minutes he used, and then he peeled 20 potatoes, right? So the final answer is 20. Okay, any questions? Okay, if no questions, let's have a look at the next one. I can finish the problems in one chapter of my physics books in 8 hours. Suppose that the problems in each chapter take the same amount of time to solve, and there are 30 chapters. How many people working together at the same rate as me? would it take to finish the whole book in one day? So we know the number of chapters completed is directly proportional to the number of people and also directly proportional to the amount of time spent, right? So basically we have this relationship, number of people used times the amount of time used over the number of chapters should equal a constant number k, right? Where k is some constant numbers there. We can find k using the information that is given there because I can solve the problems in one chapter alone in 8 hours. Therefore, k equals number of people is 1 times the amount of time is 8 hours over one chapter, right? So that equals 8. So if there are n people, if n people can tackle 30 chapters in 24 hours, we have the following relationship. Number of people is n times the amount of time is 24 hours over 30 chapters. This equals k, right? And we know k equals 8. Therefore, we can solve n must equal 8 times 30 over 24. And this gives us 10 people, right? So we need 10 people here. Again, have a look at the solution here. Any questions, just let me know, okay? All right, if no questions, let's have a look at the next one. Okay, question number 10. Janie drove 20 miles per hour to her grandparents' house. How fast must she drive on the return trip to average 30 miles per hour for the round trip? So, okay, usually when you want to find average speed, we should use total distance traveled over the total time used, right? This will give us the average speed. of course, you should be careful with the unit you use here. So if the total distance traveled is miles, total times used is in hours, then the average speed must be in the unit of mph, right? Miles per hour. So we need the distance here, but we don't know that, so we could use the letter D be the distance. This person drives. To her grandparents. And we are trying to find the speed that she drives on the return trip. So we could let, for example, V be the speed in mph for the return trip. Well, we want the average speed to be 30 miles per hour, so we could use total distance traveled over total time used, right? So basically you have 30 over V equals 2 minus 1.5, which is 1 over 2. And therefore we have V equals 60, and the unit is mph. Okay, have a look at the solution here. Any questions, just let me know, okay? Alright, if no question, let's have a look at the next one. Okay, Joey and Rainy are building a fence. Joe can build the fence alone in 4 hours. If Rainy starts helping Joe after he has already worked on the fence for 2 hours, they will finish the fence 90 minutes after she joins him. How long would it take Rainy to build the fence alone? Okay, so we have two different units here. Be careful with the units. Suppose we use the hour, not the minutes. So 90 minutes here means 1.5 hours, right? Since Joe can't build the fence alone in 4 hours, he can build 1/4 of the fence each hour. So the work rate for Joe is 1/4, right? And let's suppose it will take Rainy to build the fence alone T hours. Oh, sorry, let's use R. R hours, then the work rate for Rainy is 1/R, right? So after 2 hours, Joe has already built a fence for 1/4 times 2 hours, which is 1/2, right? Joe has built 1/2 of the fence. Suppose Rainy can build the fence in R hours, like we said here. Then she can build 1/r of the fence each hour. So this is her work rate. So Joe and Rainy can build 1/4 plus 1/r. This is a combined work rate, right, of the fence together each hour. Because they can build the remaining 1/2 of the fence in 90 minutes, which equals 3/2 of an hour. So we have the following relationship. The combined work rate, 1/4 plus 1/r, times the time taken of the work, which is 90 minutes, and convert that to hours, which gives us 3/2 hours, right? Equals the work they have done, which is 1/2, well, half of that fence. Gain one variable and one equation, you should be able to find R, right? So this gives us 1/4 plus 1/r must equal 1/3, and then 1/r should equal 1/12. And of course, R is 12, right? So that means it will take Rennie 12 hours to build the fence alone. So Andy's long has twice as much as area as Beth's long and 3 times as much as area as Carlos' long. Carlos' long mower cuts half as fast as Beth's mower and 1/3 as fast as Andy's mower. If they all start to mow their lawns at the same time, who will finish first? Okay, we know the time it takes to cut a lawn is directly proportional to the area of the lawn, right? Because if you have more lawn, it will cost you more time. And it's inversely proportional to the speed of the mower. So we must have this relationship. The speed of the mower times the time of mowing over the area of the lawn should equal a constant number k, right? Where we have, if you want to find the time of mowing, it should equal k times the area of the lawn over the speed of the mower, right? So if you let the area of Andy's lawn be a, and the speed of Carlos mower be c, and this mower is 3 times as fast as Carlos, so its speed is 3c. The area of his lawn is a, so the time it takes him to mow is, okay, so for Andy's time is k times a over 3c, which is yeah, k is 3c. Let's keep it there. And for Beth, we know this time should be k times a over 2 divided by 2c, right? Which equals ka over 4c. For Carlos time should equal k times 1/3 of a over c. This gives us ka over 3c, right? And this tells us that Carlos and Andy take the same amount of time, and Beth takes a little less time because 1/4 is less than 1/3, right? So we know Beth will finish first. Okay, do you have any questions? Alright, if you finish, let's have a look at the next one. Okay, so if the radius of the tires were doubled, the tires would make half as many revolutions on the return trip, right? So the car would register half of the distance traveled on the return trip. This makes us think that the distance shown on the instrumental panel and the radius of the tires are inversely proportional. So if we let n be the number of rotations a tire on the car makes, and let c be the circumference. Which means length around the outside of the tire. Then we have the following relationship. The distance traveled d equals n times c, right? So number of rotations and circumference are inversely proportional. To figure out how far the car goes, the car's computer also multiplies the number of rotations of a tire by the circumference of the tire. However, the computer can't get out and measure the tire, so it must be programmed to think the tire has a radius of 15 inches. In other words, it always thinks the circumference of the tire is 2 times 15 pi, which is 30 pi for the circumference. So the car's distance measurement, m, well, given by this formula, m equals n times 30 pi, right? This is car distance measured. Solving this for n, we have n equals m over 30 pi. And substituting this into our equation above, we have d equals n times c, which is m over 30 pi times c. And of course, you can put c here. So let the radius of the car of the tires be r. We have c equals 2 pi r, right? So d equals mc, which is 2 pi r over 30 pi. So that gives us mr over 15. So the radius of the tires and the measurement made by the car are inversely proportional. Because the distance of the two trips is the same, which means d is constant, so the product of the original measurement and radius equals the product of the return trip measurement and radius. Calling this letter radius x, we have then 450 times 15 should equal 440 times x, right? And you can calculate x equals 450 times 15 over 440. And this is approximately 15.34. Therefore, the radius increased by 0.34 inches. This is your final solution. All right, have a look at the solution here and let me know if you have any questions, okay? All right, have you finished? And let's have a look at the next one. Okay, 2 candles. Well, suppose the candles are lit for T hours. We know for the 3-hour candle, the remaining of the 3-hour candle is 1 minus T over 3, right? For the 4-hour candle, similarly, we have the remaining of it is 1 minus T over 4, right? And we know that's twice as much as the second candle left as of the first, so we must have this relationship. 1 minus T over 4 should equal twice of 1 minus T over 3, right? And of course, you can solve T in this equation. So this will give us T equals 12 over 5. And that's in hours, right? So basically that's 2 hours and 24 minutes, right? So 2 hours and 24 minutes before 4 p.m. is, of course, 1:36 p.m., right? So this is the time we are looking for. Any questions? All right, if no questions, Well, because we're running out of time, so we'll just pass the next one. Pass the question 18 and 19. We'll go directly to question 20, okay? Okay, so here you have two trains, each moving at 20 miles per hour towards each other. Initially 60 miles apart. Okay, let's draw a diagram to illustrate this. This is one train, this is another train. 20 mph, 20 mph, and initially they are 60 miles apart. A bee starts at the front of one train, flies to the other train, then back to the first train, and so on. If the bee always flies at 30 miles per hour, how far does the bee fly before the train collide? Okay, so we could start by first finding how far the bee flies before reaching the second train, right? And then computing how far it flies before it returns to the first train. Then how far it flies going back to the second train, and so on. But this looks like a pretty tough approach to take, so let's see if we can find another method. Okay, so we need to find the distance the bee flies, and we already know how fast the bee flies. So basically, as long as you know the total time it flies, then you know the total distance, right? So this is actually asking you to find how long does it take for the two trains collide, right? Since the two trains each move 20 miles per hour, they approach each other at 40 miles per hour, right? Therefore, they will cover the 60 miles between them and collide in this time. 60 is a relative distance, 40 miles per hour is a relative speed, right? So that's actually 3/2 hours. So basically that means in 1.5 or 3/2 hours, these two trains will collide. That means the total time the bee flies is also 3/2 hours, right? So the total distance it flies equals its speed, 30 miles per hour, times the time it flies, which is 3/2. So basically you have 45 miles, right? Did you get it? Therefore, you can make the conclusion. It flies 45 miles before the two trains collide. Any questions?
Understood. Bye. Bye. Bye.
Alright, that's pretty much about it. Then I'll see you next time. Bye.